Have you ever pondered how big the universe truly is? The answer, my friends, is nothing short of mind-boggling, a vastness that stretches our understanding to its very limits. Let's begin with a little analogy to help us visualize this immense expanse. Picture, if you will, a grain of sand, small, isn't it? Now imagine that this humble grain of sand represents our entire planet, Earth. It's a sobering thought, isn't it? Yet even this comparison falls short in capturing the sheer scale of the universe. Now let's move one step further. Suppose we were to fill an entire Olympic-sized swimming pool with these grains of sand. Each grain, remember, symbolizes an Earth. This colossal collection of sand grains, as staggering as it may seem, would still only represent a fraction of the observable universe. So just how many grains of sand are we talking about? Well, the latest estimates suggest that there are around 2 trillion galaxies in the observable universe. Yes, you heard right, 2 trillion galaxies. And each of these galaxies is home to an estimated 100 billion stars. That's a 1 followed by 11 zeros. Imagine, if you can, all those stars, each potentially with its own system of planets, asteroids, and comets. It's a mind-numbing thought that makes our Earth, our grain of sand, seem incredibly tiny and insignificant. But it's also a thought that fills us with awe and wonder, for it reminds us of our place in the grand scheme of things, of the incredible vastness that exists out there, waiting to be explored. So next time, when you gaze at the night sky, remember, you're looking at just a tiny fraction of the universe. Are you aware that over 95% of the universe is made up of stuff we can't even see? Yes, you heard it right. We're talking about dark matter and dark energy, the invisible giants of the cosmos. Let's tackle dark matter first. It's a mysterious substance that doesn't interact with light or any other form of electromagnetic radiation, which makes it, well, dark and undetectable. Yet we know it's there. How? Because of its gravitational effects on visible matter. It bends the path of light from distant galaxies and holds galaxies together like an unseen cosmic glue. Now let's shift to dark energy, even more elusive than dark matter. It's believed to be a strange force that's causing the universe to expand at an accelerating rate. Picture this. Instead of slowing down due to gravity, the universe is actually speeding up its expansion. It's like throwing a ball upwards, and instead of it falling back to the ground, it accelerates upwards into the sky. Mind-boggling, isn't it? These two mysterious entities, dark matter and dark energy, dominate the universe, yet we know so little about them. Scientists have been on a relentless quest, building complex experiments deep underground and launching sophisticated satellites into space to detect these elusive substances. But so far, they've been largely unsuccessful. Dark matter and dark energy remain shrouded in mystery, like cosmic phantoms that we can't quite grasp. The presence of dark matter and dark energy has profound implications for our understanding of the universe. They challenge our theories of physics and force us to question what we think we know. They remind us that the universe, in all its vastness and complexity, is still largely unknown territory. So, the next time you gaze at the night sky, remember that what you're seeing is just a tiny fraction of the universe. Most of it is hidden in the shadows, unseen and yet profoundly influential. The universe, it seems, has more hidden than visible, challenging our understanding at every turn. Did you know that you're moving at thousands of kilometers per hour right now, even as you're watching this video? Yes, you heard it right. We're all in constant motion, even when it feels like we're standing still. Let's start with the Earth. It spins on its axis at an impressive speed of over 1,600 kilometers per hour. That's faster than the speed of the fastest jet ever built. However, it's so colossal and we're so small in comparison, we don't feel this dizzying spin. But that's not all. While spinning like a top, the Earth is also orbiting the Sun at an average speed of about 100,000 kilometers per hour. That's nearly 30 kilometers per second. Imagine, in the time it took you to read this sentence, we've traveled the length of about 200 football fields. Then, let's zoom out a little more. Our solar system, with the Sun at its heart, is also moving. It's traveling through the Milky Way galaxy at an astounding speed of about 700,000 kilometers per hour. Yet, even at this breakneck speed, it would still take us about 230 million years to complete one orbit around the galaxy. Now let's go even further. Our Milky Way galaxy, along with its local group of galaxies, is moving through the universe too, and we're talking millions of kilometers per hour here. So as we sit here, we're spinning, orbiting, and jetting through the cosmos, all at speeds that are hard to fathom. And all of this is happening right now, even as you listen to this. So the next time you're feeling still, remember this. Stillness is an illusion, a feeling that masks the reality of our cosmic journey. Despite the calmness you might feel, remember, we're all just passengers on a spaceship called Earth. Imagine if there was not just one universe, but an infinite number of universes. Sounds like science fiction, right? Welcome to the world of the multiverse theory. This audacious idea suggests that what we've always known as the universe might just be one of an infinite number of universes. Mind-blowing, isn't it? This isn't just a wild guess or a figment of a sci-fi writer's imagination. Quantum mechanics, one of the most successful theories in physics, provides us some clues. When we dive into the subatomic world, particles behave in strange ways, existing in multiple states at once. It's only when we observe them they choose one state. This is known as the many worlds interpretation. It proposes that for each possible outcome the universe splits, creating a new parallel universe for each possibility. Then we have string theory, another groundbreaking idea in theoretical physics. It suggests that instead of point-like particles, the fundamental building blocks of matter are one-dimensional strings. This theory requires extra dimensions, as many as 10 or 11, far more than the 3 spatial dimensions and 1 time dimension we're familiar with. These additional dimensions could provide room for other universes like sheets of paper stacked in a cosmic book. But what would it mean if parallel universes do exist? The implications are staggering. There could be universes where time runs backward, where the laws of physics are entirely different, or where another version of you is listening to this very same script, but in a world where dinosaurs never went extinct. Despite the intriguing prospects, it's important to remember that these theories remain unproven. Experimentally verifying the existence of parallel universes is a colossal challenge. And even as we ponder the existence of other universes, we're still striving to understand the mysteries of our own universe. While it's fascinating to ponder parallel universes, it's equally humbling to realize that we're still striving to understand our own universe. Despite our advances in technology and understanding, did you know that we still know very little about the universe? Yes, that's right. Despite our strides in space exploration and scientific understanding, the universe remains largely a mystery, an enigma, a cosmic conundrum. The vastness of the cosmos is such that even with our most powerful telescopes, we've only just begun to scratch the surface. Take black holes, for instance. These mysterious entities are regions of space where gravity is so strong that nothing, not even light, can escape. Their existence challenges our understanding of physics, and yet, they're as integral to the fabric of the universe as the stars and galaxies we can see. The more we learn about black holes, the more questions we uncover. How do they form? What happens inside them? And most intriguingly, where does everything that falls into them go? Then there's the Big Bang. Most scientists agree that this colossal explosion gave birth to our universe around 14 billion years ago. But what triggered the Big Bang? What was before it? These questions remain unanswered, and the answers could fundamentally change our understanding of our cosmic origins. And let's not forget about the fate of the universe. Will it keep expanding forever, or will it eventually collapse in on itself in a big crunch? Or perhaps it's destined for a big freeze, where all the stars burn out and the universe becomes a dark, cold place. The truth is, we just don't know. Finally, there's the question of extraterrestrial life. Are we alone in the universe? Or are there other civilizations out there, perhaps looking up at the stars and wondering the same thing? Despite our best efforts, we've yet to find conclusive evidence of life beyond Earth. But the search continues, and the universe is a big place. As we continue to explore the cosmos, every discovery only seems to lead to more questions. The universe, it seems, loves its secrets.